Hi students, welcome to ACE Online. So this is the third section for general science, especially physics and chemistry point of view. So in previous sections we already discussed some of the most important questions, so which is relevant to your RRB JEE examination point of view. So in this section also we will continue the same thing. So you should also follow the major concepts here, and one more important announcement here it is. So a good news for RRB JEE aspirants, we are providing mostly a free mock test on 8th December 2024. So it will be conducted in between 11 AM to 12:30 PM. Okay, so it is common for all streams, so nothing but CBT-1 na? So syllabus is same for all streams, so that's why you have to utilize this opportunity. So how to enroll to write this exam? We'll provide the link below this video. Okay, so click the link and attempt to this examination. Please attempt this examination. So this is a good opportunity for RRB JEE aspirants, right? Yes. Next, here it is, the first question. The chemical name of indelible ink is? The chemical name of indelible ink: silver bromide, silver chloride, horn silver, next silver nitrate. So indelible ink. Actually guys, to prevent people from multiple voting, we are using one of the chemical derivative. Of course it is called as the derivative is called as indelible ink or electroable ink. In that electroable ink, it has silver nitrate derivatives around 40 to 45% silver nitrate chemical constituent is mostly be existed. So when it is the complete chemical composition of indelible ink mostly not revealed. Why? Because if we reveal the complete composition, so mostly we can there is a chance to make an antidote. So that's why they intimate up to some extent. So same kind of derivatives there is a possibility to get in the examination point of view also. Okay, so when we applied this type of chemical on the index finger, so within fraction of seconds it can be converted into dark color. Why? Because in the atmosphere we have ultraviolet rays. Okay, so when silver nitrate derivatives reacts with ultraviolet rays, so it can form a dark color. So that's why guys, here the correct answer is option D, silver nitrate. Next one, which of the following has electrons equal to Z plus 3? Z is atomic number of the element. Okay, right. So Z is equal to nothing but atomic number. Atomic number. Actually, the representation of an atom. Okay, if you consider any atom, it can be represented. This is the general representation form of an atom. So here it is A, and here it is Z. Okay, here it is Z. Z means atomic number. Atomic number. Next one. So this is atomic mass. Atomic mass. This is atomic number. Okay, so here they mention potassium ion. Potassium K plus. Okay, next sulfide ion S minus 2. Nitride ion N minus 3. Next carbide ion, carbide, so C minus 4. Okay, yeah, so what is the atomic number of potassium? 19. Okay, so 19. So here Z is equal to 19. So here it is looking like Z minus 1 na? Z minus 1. It means K plus means K plus means actually potassium is having 19 electrons, but here it has plus, right? So it means it loses 1 electron. So finally 18 electrons. So 18 electrons means Z minus 1. Z minus 1. In the same manner, S minus 2. So Z plus 2. Why? Because here minus 2 na? So it means it gains 2 electrons. It indicates gain of 2 electrons. So that's why we have to represent with Z plus 2. So if you consider sulfur, its atomic number mostly 16, right? 16. So minus 2 means, so addition of 2 electrons, gain of 2 electrons. Finally it has 18 electrons. 18 electrons. So 18 means so 18 means nothing but Z plus 2. If you add 2 electrons, then only we can get 18 electrons for this atom. Next nitride ion. So nitrogen, atomic number 7. Next here addition of 3 electrons, so it means Z plus 3. Here in the same manner Z plus 4. So what about the given one? Which of the following has electrons equal to Z plus 3? So that's why guys we have to consider option C is the right answer. Option C. So N minus 3. This is called as nitride ion. Nitride ion is considered as the correct option here. Next, the working of quartz crystal in the watch is based on Edison effect, photoelectric effect, piezoelectric effect, next Johnson effect. Yes, so piezoelectric effect, this is the correct answer. Why? Because quartz means if you consider mostly quartz watches. Okay, here we have quartz watches. Here we have quartz in the form of SiO2, and its shape would be just like tuning fork. So when it is connected with a battery, it means when electrons are transferring through this material, mostly it exhibits some vibration. Okay, it exhibits some vibration. So based on the vibration, we can get the time. Okay, so that's why here here we get the time based on the vibrations of the quartz. So due to that, these type of watches are called as quartz watches. So finally here the content is how to produce ultrasounds, or what kind of material is majorly used in piezoelectric method? Silicon dioxide. This is called as quartz. Silicon dioxide is considered as quartz. That's why option C is the right answer. Okay, right. So next one. If you move towards a plane mirror at a speed of 10 centimeters per second, at what speed does your image approaches you? Okay, right. So here they mention if you move towards a plane mirror. Okay, so plane mirror at a speed of, so speed is equal to so distance by time, displacement by time, right? So distance by time. So here distance by time means x by t. So what does your image approaches you? What does your image approaches you? So here guys, here the formula to get image approaches especially in the plane mirror is 2x by t. Okay, we already know that x by t is equal to 10 centimeters per second. 10 centimeters per second. So here it is the formula 2x by t. So that's why 2 into 10 centimeters per second. So finally what we get? 20 centimeters per second. 20 centimeters per second. So due to that, here we have to consider option C is the right answer. Okay, so if we move towards a plane mirror at a speed of 10 centimeters per second, at what speed your image approaches to? So you should follow this equation, and here they mention x by t. So the value is 10 centimeters per second. If you substitute the value, finally we can get 20 centimeters per second. Okay, right. Next, raindrop or spherical due to. Okay, if you observe raindrop, it should always, mostly it exhibit a spherical shape only. So it does not exhibit either triangle or elliptical or a square. Okay, so what is the reason behind that? Actually guys, if you consider solids, next liquids, next gases, in these three things, which one is having rigid type of arrangement? Solid. So these two are not having particular shape. So that's why these are considered as fluids. Okay, fluids. Especially this liquid is treated. This liquid is having two types of forces. Of course, liquid and gases, these two are considered as mostly fluids. Okay, liquid is having two types of forces. One is cohesive force, and the second one is adhesive force. Cohesive force means attraction exists in between same kind of molecules. Okay, so same kind of molecules. So what about adhesive? Attraction exists in between different types of molecules. Okay, so these are cohesive forces are always stronger than the adhesive forces. If you considered water molecules, okay, or if you poured water on the floor or water on the surface, mostly here we have a number of water molecules now. So around 10 power minus 13 meters, 10 power minus 10 to 10 power minus 13 meters. So almost all these water molecules are attracted towards the center of the molecule na, okay, so towards this molecule. Why? Because here we have a water molecule and the center of this region is also having water molecule, means same kind of molecules are there. So then what kind of forces are mostly be existed? Cohesive forces. So because of cohesive forces, so mostly it shows spherical nature na, spherical in shape. So this phenomenon is called as surface tension. Okay, this phenomenon is considered as surface tension. So raindrops are spherical due to option B, surface tension. Okay, so surface tension, option B is the right answer. Okay, it's next one. Identify the correct statement from the following. CFC is responsible of depletion of ozone layer. Of course, if you observe chlorofluorocarbons, it emits chlorine free radical. Each chlorine free radical can collapse 1 lakh ozone molecules. 1 lakh ozone molecules just like this, O2 plus OCl dot. This is called as ozone depletion. This is treated as ozone depletion. So that's why statement 1 is correct. CFC is responsible of ozone layer. Next, water vapor, carbon dioxide, methane, nitrous oxide, chlorofluorocarbons are greenhouse gases. Of course, water vapor, carbon dioxide, methane, nitrous oxide, chlorofluorocarbons, hydrofluorocarbons, okay, so sulfur hexafluoride, almost all these are considered as greenhouse gases. That's why statement 2 is also correct. Next, BOD value of pure water is 100 ppm. ppm stands for parts per million. If you consider pure water, okay, actually water purity indicates in the terms of BOD, next COD and DO, okay, so DO. If BOD value increases, purity of water decreases. If COD value increases, purity of water decreases. If DO value increases, purity of water also increases. BOD increases means amount of oxygen decreases. COD increases means amount of oxygen decreases. DO increases means amount of oxygen increases. So it means, guys, how to estimate the purity of water based on the existence of oxygen molecules in the given water samples. So here BOD value of pure water, they mentioned 100 ppm na. We already know that BOD increases, amount of oxygen decreases. If BOD value is high, the water is not treated as pure. Actually pure water BOD value is less than 5 ppm only. Less than 5 ppm only, but here they mention 100 ppm na. So due to that it was completely wrong. So option 1 and 2 are correct here only. Okay, it's next one. A steel ball float on mercury because, okay, so mercury, it indicates with Hg, nothing but hydrargyrum. This is the Latin name, hydrargyrum. Okay, this is also called as quicksilver. So actually mercury is a metal. When mercury react with any metal, it is called as, okay, so group of metals na. So group of metal, here it is metal, and when we add some other metals, so what we get? Alloy. What is the name of mercury alloy? Amalgam. Okay, amalgam. You should also remember that almost mercury can react with any kind of metal except iron and platinum only. Okay, so by these two elements it does not produce any amalgam derivative. Okay, so and one more interesting point, mercury is also having high density. Of course in periodic table osmium, okay, osmium exhibit a highest density. Next, mercury is also one of the constant. Yes. So when steel ball, let's consider, here it is the mercury. Next, when steel ball added on the mercury, so then what will happen? The mercury does not allow any metallic ball to sink in it. It is wrong. Suppose if the density of the steel is high, okay, if the density of steel is high, mostly it submerged into the mercury or it sink into the mercury. Next, or if it is less than the density of mercury, it is completely floated on the mercuric derivatives. Na? So that's why option A is wrong. Next, mercury is also metal in the liquid form. Of course, it is a liquid state metal at room temperature, but the statement is not appropriate to the given one. Next, the density of mercury is higher than that of steel. Yes, so the density of mercury, suppose if the density of mercury is higher, then only steel can float on the surface of mercuric derivatives. So that's why guys, option C is the right answer. This is one and only possibility. Actually these are considered as law of flotations. Okay, so law of flotations. So these law of flotations were proposed by whom? Mostly Archimedes. Yes, so we already know that. So this is the liquid state metal. You should also remember remaining constituents. Okay, what I mentioned here, the Latin name of mercury. Next, it is also called as quicksilver. Why? Because it appeared in silver orientation. Appearance would be silver, but it is not just looking like that. Okay, just looking like that. So when we add any type of metal within fraction of seconds, almost all the metallic constituent can easily be dissolved in that, except iron and platinum. These two are not react with mostly mercuric derivatives. Alright, next one, match the following. Here they mention HCl, H2SO4, copper sulfate, iron sulfate. Alright, so HCl, this is called as muriatic acid, muriatic acid, okay, or hydrochloric acid, gastric juice also, gastric juice. So stomach acid also, okay, number of terminologies it has. So that's why here the correct one is HCl. Next, H2SO4, okay, H2SO4. Actually here it has sulfate derivative, na. So in Latin name, sulfate derivatives are called as vitriol. So this is considered as oil of vitriol, and it is also called as king of chemicals. So here it is the correct match. Next, copper sulfate. How many water molecules it has? 5. So here this is considered as blue vitriol. Okay, so copper sulfate, CuSO4. If it is having 5 water molecules, then only its color would be blue. Okay, color would be blue. Actually these are called as ligands. Okay, so ligands. So from ligand to metal, electrons transmission takes place. Due to that, here this compound exhibit blue color. Okay, what kind of transmission is takes place here? Ligand to metal. Okay, ligand to metal, electron transmission takes place here. Right, so without water molecule, what we have? Copper sulfate. So what is the color of copper sulfate? Colorless. That is the beauty of existence of water. Next one, ferrous sulfate. Here it has 7 water molecules. This is called as green vitriol. Okay, so 1, what we get? 4. So mostly. Next 2, 3. Next copper sulfate. So 1. Copper sulfate 1. Next fourth one is 2. 4, 3, 1, 2. 4, 3, 1, 2. Option B is the right answer. Right, 1 nautical mile is equal to, this is also basic terminology, basic type of questions, 1.82 kilometers, 1.852 kilometers. So here this type of questions are also mostly expected in your examination point of view. Actually guys, 1 nautical mile is equal to 1.852 kilometers. Okay, 1.852 kilometers. So 1 minute of latitude is equal to 1 nautical mile. You should also remember that 1 minute of latitude, 1 minute of latitude. Here it is, 1 minute of latitude is generally considered as mostly 1 nautical mile, 1 nautical mile. So its value would be 1852 meters. In kilometers, 1.852 kilometers. Okay. Yes. So here the correct one is option B. Option B, 1.852 kilometers. Next one. The correct increasing order of global warming potential of carbon dioxide, nitrogen dioxide, methane, chlorofluorocarbons. Chlorofluorocarbons. Actually, global warming potential, GWP, global warming potential, global warming potential. Yes, global warming potential means, let's consider one example. Here it is the planet Earth. So in this atmosphere we should fill carbon dioxide. First, just for sake of our convenience, it has only carbon dioxide. Let's consider like that. Okay, right. So how much amount of temperature mostly be raised by the existence of carbon dioxide? Let's consider the value is 1 unit. 1 unit. So this is first case. In the second case, instead of carbon dioxide, if it is filled with methane, okay, so if it is filled with methane, it means in this atmosphere it has only methane molecules. Then how many times this planet temperature can be raised compared with carbon dioxide in 100 years? 21 times. 21 times. Okay. Next, nitrous oxide, N2O. N2O, this is methane, this is about carbon dioxide. So nitrous oxide around 342 times, 342 times. In 100 years it can rise around 342 years, just approximate value. Next one chlorofluorocarbon, so CFC, 10,200 times. Compared with carbon dioxide, it can rises this planet temperature around 10,200 times. It means global warming potential values should always compare with carbon dioxide, that too in the duration of, okay, so that too the duration, up to the duration of 100 years only. In 100 years, how many times methane can rise the temperature? Mostly 21 times. What about nitrous oxide? So 342. What about chlorofluorocarbons? 10,200 times. So this is the order. Okay, so this is the order. Mostly chlorofluorocarbons, next one nitrous oxide, next one methane, next carbon dioxide. That's why option, yes, so that's why option D is the right answer. Okay, so CFC, actually CFC, okay, so they mention sorry, so this is the, so CFC is having highest global warming potential when compared with nitrous oxide, at the same time methane and carbon dioxide. Okay, right. So next one, match the following. Avogadro number, next charge on the electron, Planck constant, Faraday. Avogadro number indicates with N. Okay, so 1 Avogadro number is equal to 6.023. Avogadro number is equal to 1 mole is equal to 6.023 into 10 power 23, which is equal to gram molecular weight, which is equal to 22.4 liters. 22.4 liters. 4 liters. Okay, right. So here they mention 6.603 into 10 power 23, yes. 6.6023 into 10 power 23 molecules. This is molecules or atoms, whatever it is. Next, charge of the electron. So charge of the electron, okay, so what is the charge of electron? Here it is, minus 1.602 into 10 power minus 19 coulombs, okay. So 10 power minus 19 coulombs, right. So next one, Planck constant. So Planck constant value 6.625 into 10 power minus 34 joule second. So joule second, so that's why option is, okay. So next one, Faraday. 1 Faraday is equal to, so 1 Faraday is equal to 96,500 coulombs. So RTSU is option C is the right answer. Next one, match the following: nano, pico, micro, milli. Next, atto. So nano is equal to 10 power minus 9 meters. Next, pico is equal to 10 power minus 12 meters. Next, micro is equal to 10 power minus 6, okay, micro 10 power minus 6 meters. Next, milli, okay, so milli is equal to 10 power minus 3 meters. Next, atto, which is equal to 10 power minus 18 meters, 10 power 18 meters, okay. So this is the explanation for the given option. So nano, here it is R. Next, pico 10 power minus 12, RS atto. Next, mostly option B is the right answer. Option B is the right answer, okay. Yes, next one, match the following: mercury thermometer, platinum resistance thermometer, thermocouple thermometer. Next one, constant volume hydrogen gas thermometer. Yes, so here guys, they mention some of the thermometers and their ranges. Okay, so generally we are using mercury thermometer na. Clinical thermometer, that is completely different. So compared with the mercury thermometer, of course in clinical thermometer we are using either mercury or alcohol, okay. In these two things, which is the most convenient one? Alcohol thermometer. Even at low temperature also, alcohol thermometer is more efficient than the mercury thermometer. Consumption of mercury, suppose in that thermometer, if there is any leakage, mostly consumption of those derivatives, what we get? Minameta. The disease minameta. So due to that due to that, alcoholic thermometers are more convenient than the mercury thermometers. But here it is completely different than that. So mercury thermometer, actually its range is minus 30 degrees centigrade to 350 degrees centigrade. Next, platinum resistance thermometer. It can be used to measure high temperature. Actually minus 200 degrees centigrade to 1600 degrees centigrade. Next, thermocouple thermometer. Okay, so thermocouple thermometer. Yes. So mercury thermometer, option A, mercury thermometer, its range minus 30 degrees centigrade to 350 degrees centigrade. Okay, next B, C, next D, right. Hydrogen thermometer, its range minus 200 degrees centigrade to 500 degrees centigrade, minus 200 degrees centigrade to 500 degrees centigrade, okay. So that's why here we get 2 na, option D 2, right. Next, option 1 4, okay, right. Next, platinum thermometer. Yes, so actually here minus 200, here also they mention same values na. So compared with platinum thermometer, thermocouple thermometer range would be somewhat high. So that's why here we have to consider like this. So platinum thermometer value would be minus 200 degrees centigrade to 1200 degrees centigrade. Next one, thermocouple thermometer. So minus 200 degrees centigrade to 1600 degrees centigrade. 1600 degrees centigrade. So finally guys, here the correct answer is option 4. Option 4. Okay, yes, next one. Among these thermometers, which is more efficient, okay, more efficient, it means even smaller values can also be analyzed by which one of the given thermometer. So mostly gaseous thermometer. It means this one. This is the best one compared with the remaining things. Why? Because here the heat energy carrier would be liquid. Next, platinum thermometer. Next, thermocouple thermometers. In these two things, mostly we are using solid related derivatives. Na? So mostly solids, liquids, gases. In these three things, so even smaller variation can also be analyzed by the using of gaseous thermometers. Why? Because suppose if you consider 1 degree rise of temperature, especially in solids, mostly its expansion would be like this. Next, liquids, its expansion would be like this. Next, in gases, mostly its expansion would be like this. So here it can be easy to divide 10. Here it can be easy to divide even more than 10. More than 10. That's why. So expansions and contraction. So minor expansions and minor contractions are also easily analyzed by these gaseous thermometers. Okay, that's why you should also remember the importance of gaseous thermometers. So the next one, tomatoes contains an acid X. Tomatoes contains an acid X. What kind of acid is mostly exist in tomatoes? Tomato, spinach. Okay, oxalic acid. Oxalic acid. Next, apple contains acid Y. Actually, in apple it has malic acid. So what are the X and Y respectively? Oxalic and malic acid. Option D is the right answer. Actually, oxalic acid is used to remove rust stains. Okay, rust stains from the clothing. You should also remember that. The chemical, which is the most commonly used chemical to remove rust stains from clothing. Then you should consider oxalic acid. Okay, right. So conventional energy source is, actually guys, energy sources are classified into two types. One is renewable. Okay, so renewable energy, renewable. And the second one is non-renewable energy. Non-renewable. Okay. So in renewable energy, what are the major examples? Solar, next wind, next tidal, next wave energy, next biogas, waste to energy. Almost okay, so ocean thermal energy conversion, almost all these are considered as the major examples of renewable energy. What about non-renewable? Again, these non-renewable classified into two types. One is fossil. Okay, so fossil fuels. Second one is non-fossil fuels. Fossil fuels means petroleum, natural gas. Okay, natural gas, petroleum. Next one, shale gas. Okay, shale gas and coal. These are all considered as fossil fuels. What about non-fossil fuels? Mostly radioactive elements. Radioactive elements like uranium, thorium, plutonium. So by using these derivatives, we can produce the nuclear power. Actually, here they mention about conventional energy, na? That's why we have to consider option D, nuclear and nuclear power. Remaining are treated as conventional energy sources. Of course, conventional energy sources are also called as non-renewable energy sources. Okay, so non-conventional sources, energy sources are also called as renewable energy sources. You should remember this terminology. Next, the chemical name of aspirin. Actually guys, aspirin is made up by the acetylation of salicylic acid. This is salicylic acid. Salicylic acid. When this salicylic acid get into acetylation, okay, acetylation. So here acetylation takes place. Actually this hydrogen can be replaced by CH3CO. Then what we get? Instead of this hydrogen, it can be replaced by CH3CO. This is called as acetyl group. So finally this is called as acetyl salicylic acid. Okay, acetyl salicylic acid. This is the chemical name of this derivative. So this is considered as aspirin. Okay, aspirin. So that's why option B is the right answer. This is the world most widely used chemical. Sorry, the world most widely used drug. Okay, drug or medicine, not paracetamol. Next, match the following: law of conservation of mass, law of definite proportions, law of multiple proportions. Next, mole concept. So law of conservation of mass, it means mass neither be created nor be destroyed. It just convert from one form to another form. Suppose if you consider calcium carbonate, when it is heated, what we get? Calcium oxide plus carbon dioxide. This is endothermic reaction. It means it requires energy. Here calcium mass 40, carbon mass 12, oxygen mass 16, 3 into 16 48. Finally what we get? So 100 AMU or 100 units. Okay, next. So calcium oxide. So mostly 40 plus 16. Next carbon dioxide 12 plus 2 into 16. Okay, 44, here it is 56. So right side mass 100 units, left side mass also 100 units. So it means in this there is no change in mass, right? There is no change of mass. So left side and right side, and it means reactant mass and product mass would be same. So because of that, this is considered as law of conservation of mass. Actually it was proposed by Lavoisier. Okay, so Lavoisier. So next one, law of definite proportions. If you make a chemical compound like water, so what does it need? Mostly hydrogen and oxygen. How many moles of hydrogen it needs? 2. Next, how many moles of oxygen it needs? 1. Okay, so 2:1. So 2:1 means, so 2 into, how many hydrogens it has? 2 hydrogens. Next, how many oxygens it has? 16. So finally here 4:2, so 16. 4:, sorry, each one 16, no? 2 oxygens, right? That's why we have to consider 32. So 2:2, 16, 1:8, 1:8. So if you make any chemical compound, here the reactants mass would be always constant. So if you make water, you should follow this same mass. Okay, so this mass ratio. Suppose if a noble laureate make water molecule, they should also follow the same mass ratio. Otherwise it's not, otherwise it's it's impossibility to get water. This is called as law of definite proportions. Actually it was proposed by Joseph Proust. Okay, right. So next one, law of multiple proportions. When a fixed mass of element reacts with another element like oxygen, then it forms number of chemical compounds, N2O, N2O2, next N2O3, next N2O4, like that. So the mass of one element is all, okay, the fixed mass of one element when reacts with other element, then what will happen? The second element mass would be almost 1:2, 2:2, 3:2, 4:5, just like that. It means it follows simple whole ratio. How many oxygens? Here we have 1. What about here? 2. Next 3. Next, so if it forms 4. Next, if it forms 5. So that is considered as simple whole number ratio. Okay. So this concept was actually proposed by, law of multiple proportion concept was actually proposed by John Dalton. Okay, right. So next, mole concept. Mole concept was proposed by Avogadro. Nothing but P. So QRSP. Option A is the right answer. So the volume of carbon dioxide gas liberated at STP by heating 5 grams of pure limestone. Suppose guys, if you consider calcium carbonate, Okay, calcium carbonate, when it is heated, what we get? Calcium oxide plus carbon dioxide. So what is the mass of carbon dioxide? We already know that, already here we solved, no? So here 100 AMU. Okay, if you substitute that one, 100 AMU or 100 U, how much amount of calcium oxide we get? 56 AMU. Next, what about carbon dioxide? 44 AMU. So if you consider 100, okay, instead of AMU, if you consider grams, okay, for 100 grams of calcium carbonate, how much amount of carbon dioxide can be formed here? 44 grams. Okay, 44 grams of carbon dioxide mostly we get from 100 grams of calcium carbonate. Suppose if you choose, okay, if you choose 5 grams, then what will happen? So before going to that, here we should consider Avogadro number. Avogadro number is equal to 1 mole is equal to next 6.023 is into 10 power 23 is equal to 22.4 liters is equal to gram molecular weight. Gram molecular weight. So what is the gram molecular weight of calcium carbonate? Gram molecular weight of calcium carbonate. They mention, okay, so here we get 100 na. If you add grams, then that is treated as gram molecular weight of calcium carbonate. If you consider 100 grams, so then it is equal to gram molecular weight. 1 gram molecular weight is equal to how many liters? How many liters of this is gram molecular weight of calcium carbonate. Next, what about gram molecular weight of carbon dioxide? 44 grams. Okay, 44 grams. So 44 grams means how many liters? 22.4 liters. How did we get this this terminology? If you substitute, so 1 gram molecular weight of carbon dioxide, that is 44 grams. 44 grams of carbon dioxide is equal to 22.4 liters of 22.4 liters of carbon dioxide. No? Yes. So finally, if you observe 100 grams of calcium carbonate, it emits 44 grams of carbon dioxide, which means okay, 100 grams of calcium carbonate is equal to 44 grams of carbon dioxide, which is equal to 22.4 liters. Why should we consider 22.4 liters? Actually, this is the gram molecular weight of carbon dioxide. Okay, gram molecular weight is equal to, we already know that, 22.4 liters. That is the meaning of Avogadro number. So that's why we have to consider like this. Okay, so next, suppose if you consider 5 grams of pure limestone. Okay, 5 grams of pure limestone, then how much amount of calcium, how much amount of carbon dioxide can form? What is the half of the amount of 100? 50. Okay, so what about this one? 22 grams. So here it is 50 grams. For 50 grams we can get 22 grams of carbon dioxide. So what about 5 grams? By 10, here also by 10, then we can get 2.2 grams of carbon dioxide. 2.2 grams of carbon dioxide. In the same manner, here also we can get this concept. Okay, so don't be confused. Yes, so 22.4 liters na, half of the amount 11.2 liters. Next, by 10, 1.12 liters. Okay, so that's why 1.12 liters is the right answer. Option D is the right answer. So guys, here we just used this equation in different form. So if you know the Avogadro number relation, then you can easily solve that one. For 100 grams of calcium carbonate, we can get 22.4 liters of carbon dioxide. What about 5 grams of carbon dioxide? Mostly, okay, what about 5 grams of carbon dioxide? 100 grams, we can get 22.4 liters. What about 5 grams? Actually, we don't know the answer, right? So if you cross multiply these two things, finally you can get 1.12 liters. So in that orientation also you can simply solve that one. Next, which of the following is pentaatomic molecule? So pentaatomic molecule means atomicity. Okay, atomicity is mostly 5 only. So phosphorus P4, here atomicity 4, sulfur S8, atomicity 8, ethane C2H6, 2 plus 6 8. Next methane CH4, 1 plus 4 5. So that's why methane is having pentatomicity. Which of the following is a physical change? Physical change means chemical formula should not be varied. Okay, so it means chemical formula should be same, then only that would be considered as physical change. So but here left side components, right side components, both are not same. That's why this is a chemical change, not a physical. Next, ice, water, water vapor. Of course, ice, what kind of chemical composition it has? Water, H2O. Here also H2O. Here also H2O. So if you heat or if you cool the given derivatives, so there is no variation of chemical composition. That's why B is physical change. Next, ammonium nitrate. Left side, right side products are not same. That's why this is chemical change. Next, zinc oxide, and here it is zincite. Zincite means nothing but zinc oxide. So here also zinc oxide. Formula is same. That's why it is considered as physical. Next, so left side, right side components are completely different. Na? So due to that, here it is treated as chemical change. Chemical change. Okay. So what are the correct answer here? B and D only. B and D. Option D is the correct answer here. Why? Because physical change means chemical formula should be same. Okay, chemical formula mostly not varied. Suppose if the formula is varied, then that is considered as chemical change. Next, which of the following chemical compounds exhibit sublimation? Menthol, sodium benzoate, ice, phenol, iodine. Sublimation means solid directly converts to gas without formation of liquid. This process is called as sublimation. Mostly menthol, sodium benzoate. Okay, ice does not exhibit this phenomena, but dry ice means solid carbon dioxide. This one can exhibit sublimation process. Phenol, it is also not possible. Mostly iodine can also exhibit sublimation. So 1, 2, 4, 6. 1, 2, 4, 6. Option B is the right answer. Next, match the following: Tollens reagent, failing reagent, reducing sugar, non-reducing sugar. Next, artificial sugars. Suppose guys, Tollens reagent means this is the combination of ammonical silver nitrate. Yes. Next, failing solution. Failing solution means sodium citrate and copper sulfate. Actually, these two reagents are used to estimate the presence of aldehydes and ketones. Reducing sugars. Reducing sugars means, suppose if you consider any carbohydrate, if it gives positive test with Tollens and failing solution, mostly those are called as reducing sugars. Here what we have, this ammonical silver nitrate, sodium citrate, reducing sugars, saccharin, starch. Next, non-reducing sugars. Non-reducing sugars means it does not react with Tollens and failing solution. Okay, so that's why here it concerns to starch. Actually, starch is not give positive test with Tollens and failing solution. Next, artificial sugar, saccharin. Saccharin is treated as artificial sugar. So Q. Next, first one is SQ. Sodium carbonate, sodium sulfate. Actually, here the option is wrong. If you considered glucose, then only it is correct. Okay, glucose. Next, non-reducing sugar, R. So option C is the right answer. Okay, just here you should modify the given option as a glucose. Okay, right. So guys, this is about today's class. We covered almost major concepts. Okay, and one more important announcement. We already delivered about RRB JE free mock test. So we will conduct on 8th December 2024. Okay, in between 11 a.m. to 12:30 p.m. So we will provide the link under this video. Okay, so you have to enroll your number. Next, this is completely online mock test. Here we are providing this mock test only in English language. Okay, so it's completely free of cost. That's why you have to utilize this opportunity, right? All the best. Thank you.